Hey, welcome to my channel. And today we have on our bench a Taco 007, which is really common. Got a lot of these hanging around, and they're pretty robust, well-engineered pieces of equipment. And today we're going to take a couple of these apart and get into what makes them tick. So without further ado, this particular one, the earlier version, this is from 1998. They got 4 screws with 5/16 heads on them. These are 1024 thread. And sometimes they're a little difficult to get off, particularly if this thing has gotten wet. And this particular one in the corner here is can be a bit of a challenge. They're close to the electrical connection box there. And we got this one here. Save those guys, because in theory this is rebuildable. Sometimes you need a screwdriver to pry this apart, and there is the impeller. As you can see, this has been used, and this is the cartridge. That hole there is where water can flow inside of this particular cartridge. There's the date code on the back. Set that aside. There is a plate here and an O-ring, which if you ever decide to have this, ever try to replace the cartridge and without unbolting this, which you might want to do in certain circumstances, got to replace that O-ring. You got to be careful when you put this back together again. That is the outside coil. It should never come in contact with water, of course. And this part here, as I said, is called the volute, and you've got gaskets which fit inside of here. This is what they look like new. Fairly easy to get a hold of. So we take this cover off. The old screws were, this is 8/32. They tend to disappear very quickly, and the covers tend to disappear fairly quickly too. And you've got 2 wires. One is yellow and one is white. I don't think it makes any difference which way you hook it up. This is AC powered by 120 volts, and you have a capacitor which is 5 microfarads, I believe. Yep, and you've got a ground screw there. So let's hook this up and see what happens. I'm putting hot on the yellow and the white on the neutral. Power this thing up. Reach for the switch there. And as soon as I close it, I have a little detector. Let's see if I can get there's the indicator for AC fields. And here we go. And there we are. So we got an AC field flowing. And we don't want to run it too long. The coil will heat up. There is, I believe, right here, Yeah, it didn't get too warm. There's a slight warmth to it. Right here underneath this coil winding is an impedance protector, a little temperature sensitive device, which will shut this down if it gets too hot. So let's see what happens when we put this in here. Now, when I got this and opened this up this was frozen, and so I was able to free it up by grabbing this and getting it to spin. So actually we want this to spin in this direction, or looking at it from top down, the clockwise directions, to see what happens. Yeah, there she goes. You don't want to run it too long like that, or it burns out the bearings. So you don't want to run this dry. This is designed to have water flowing inside the cartridge here, and this cartridge is designed to be replaceable, although these things are so ubiquitous, it's almost easier just to buy a whole new circ and bolt it up in most cases, not in all cases. So that is this circulator, and let's set this aside and look at one of a slightly more recent vintage. Now, this one here had the capacitor stripped out of it for reasons. The new capacitors are available for a price. You can check that on supplyhouse.com. You can figure out whether that's worth it or not for you. Sometimes it is. Sometimes that's the only thing that's wrong. You throw in a new capacitor. I think that's what happened to this guy. The cover's gone. Who knows where that went. The sheet metal, this is a sheet metal screw now rather than a machine. Cut cost, this is from 2015 manufacturer, and rather than depending on the rating plate being put on something that can be lost, they stuck it on the back here, which is I think a little bit better. Again, the same basic shape, but and also yes, the ground screw is also a sheet metal screw rather than machine. And so let's take this apart. A little different here. In general, a T-handled Allen set of 5/32 will get these screws out. I've already had them out. And again, the threads are the same. I think this is half inch by 1024, and with a 5/32 Allen. So out this comes. Sometimes you have to do this when you get this out of the box and replacement in order to get the junction box in the correct location. You don't want to have it underneath the circulator. You want to have it on the top or the sides. And of course you want to have it accessible. So this comes apart. You can see the O-ring is nice and fresh. Let me see what I can... where is that? The volute is basically the same, but they're using less metal. You can see this O-ring here is pretty squashed in. They've got an outer coating of black paint and then an inner coating. Then they overspray. Once they've machined this, they sprayed it with a gray paint, I guess, to indicate that this was, make sure they could judge in the process whether or not this was machined, I'm assuming. we set that aside. And so we have, remember, we have no capacitor in this unit. There we go. And you see the difference also that the windings are now encapsulated in this plastic. There's the difference between a decade and a half of design. The same number of whatchamacallums down there. Poles. Yeah, that's it. All right, so we turn it on, and we're going to check for flow here. All right. And again, so we do have electric flow. Capacitor doesn't change that as expected, but you can see, look at that, it's nice and new. There's your date code. Let's see if I can see that. Yeah. February of 2015. Fairly snug fit. And now we'll go ahead and apply current to that. All right. And it'll spin, but it won't spin on its own. Now I'm going to spin it clockwise. And now we're going to power this up. Nothing happens. And now I'm going to spin it counterclockwise. So it'll spin in either direction if there's no capacitor, if you can get it to, if you can kind of kickstart it. So that's what the capacitor does. My understanding is that, hard to see in there, but there are actually two different fields. There's a main field, and then there's a smaller fewer turns hooked up to the capacitor. The idea is that capacitor delays somewhat the current or the magnetic flux, and so it induces a turn, a torque, which gets it going, and then the main field can catch it and spin it around. So the next part of the show is, well, what's in this guy? Well, I tried finding out. A bit of a struggle getting into this thing. This is the stainless steel outer shell that I had to sort of peel away. And what was in here was the stator. And this is one that failed in the field. And so that is what you've got inside. I tried cutting it, and the bandsaw was having none of it. I'd still be cutting if I had tried to do that. There's the impeller. That hole goes all the way through there, so water can get into the back. This here corresponds to this crimp here, and so that will hold this in place, and this is the front bearing. It's in this particular version from 2001, it is brass. I assume it's still brass. It may or may not be. I don't know. I'm not going to cut, I haven't cut one open enough of these yet. This is my first time cutting one of these guys open, probably the last. This looks like some kind of cup seal there to keep water from flowing too much. Water should circulate around. This rear bearing is locked in place, and I think you can see there's a a buildup of minerals. This was hooked up to a well system, so there was a fair amount of minerals in the well water. It also came out of a Burnham revolution, and so this was the primary circulator, and so saw the hottest water and moving through the boiler. And it also had attached to it a electronic device which would reduce the speed of this by chopping the waveform so that this would spin slower. So I suspect what happened was that the water in this chamber got so hot it started to boil away, and more well water came in. Of course, it's a little bit over time. The water would boil away and leave behind this deposit. You can see it's been rubbing against there, and it lasted maybe 20 years. Maybe it failed. Who knows exactly when it failed? There was, but definitely it failed in the past couple of months to stop the flow. And the boiler worked because there was a secondary circulator which kind of kept some water flowing, but this one was definitely toast and needed to be replaced. I don't know how long the other one's going to last, but under advice of the technical service from Burnham, I removed disconnected the flow control, and so now the circulator that's there now will run 100% all the time. It's baseboard heat. So that's it, folks. I hope this was useful and or at least partially enlightening. Usually don't get a chance to take these apart. We're just switching them out, trying to get the heat on. I've taken the time to we've taken the time to look at this thing, and I hope that we meet again. Take care.